Previously, I made a video on the proof of my formula that I have discovered. That is why today I am going to demonstrate the uses of my formula in this video. It is useful in many branches of maths like algebra, polynomials, quadratic equations, etc. But wait, before watching this video, you might want to check out the proof of my formula and you can find it here. And yeah, this video is very useful and might be helpful in solving math problems related to algebra. So make sure to watch this video completely. Okay, now let's get into the video. Here we are going to discuss two cases in which the formula is useful. And the second one is the most important because maybe we can solve the problems related to first case even without the formula. Illogically so. But we cannot solve the second case problems without the formula. So now let's dive into the first case. Imagine that you've been given a quadratic equation x square minus a minus b divided by 2 whole square times x plus b minus a whole square divided by 4 is equals to 0. And you're asked to find the sum of the inverses of the given quadratic equation's roots. Basically, we are asked to add the inverses of the roots of the quadratic equation that we have been given. So let us assume the roots of the given quadratic equation as alpha and beta. Just two roots because the number of roots of an equation is equals to the degree of that equation. That is why we have assumed only two roots alpha and beta as our equation is a quadratic equation. Oh, I'm sorry. For those who don't know what roots are, roots, zeros and solutions are the same. They are the values of the variable in an equation. Now, people who have a basic knowledge in polynomials might know that sum of the roots alpha plus beta is equals to the negative of coefficient of x divided by coefficient of x square. Whereas the product of the roots alpha beta is equals to constant term divided by coefficient of x square. The term that is not associated with x square or x is known as constant term. Here in our quadratic equation, the constant term is b minus a whole square divided by 4. The coefficient of x is the negative of a minus b divided by 2 whole square. Coefficient of x square is 1. So now alpha plus beta will become equal to the negative of minus of a minus b divided by 2 whole square whole divided by 1, which is equals to a minus b whole square divided by 2 square. Finally, alpha plus beta will become equal to a minus b whole square divided by 4. And alpha beta is equals to b minus a whole square divided by 4 whole divided by 1, which is equals to b minus a whole square divided by 4. Okay, we have found alpha plus beta and alpha beta. But what is our main goal to find so? It is sum of the inverses of the roots of our quadratic equation, right? It can be mathematically represented as 1 by alpha plus 1 by beta. As 1 by alpha is the inverse of alpha, 1 by beta is the inverse of beta. And their sum is 1 by alpha plus 1 by beta. So now let's solve for this thing. The LCM of alpha and beta is alpha beta. So the denominator becomes alpha beta and the numerator will become alpha plus beta. Now substitute the values of alpha plus beta and alpha beta. Division becomes multiplication by multiplying the numerator's fraction with the inverse of denominator's fraction. Here both 4's will be cancelled and the final fraction that we'll get is a minus b whole square divided by b minus a whole square. A minus b whole square and b minus a whole square will be cancelled as they are equal according to our formula. Finally, you get 1 by alpha plus 1 by beta is equals to 1. Now let me show you how people generally solve this problem. 1 by alpha plus 1 by beta is equals to alpha plus beta divided by alpha beta. substituting the values of alpha plus beta and alpha beta. Again, both 4's will be cancelled. A minus b whole square and b minus a whole square are expanded to their respective identities. Rearranging the terms, as a into b is equals to b into a, 2ab will also be equals to 2ba. Finally, we get 1 by alpha plus 1 by beta as equals to 1. But this method makes no sense. You won't even get the idea to extend these identities. Because before knowing that a minus b whole square is equals to b minus a whole square, your brain was always on the thing that a minus b whole square is not equals to b minus a whole square. Now it's your choice to choose the way you solve these kind of problems. We have completed the first case and now we are heading towards the second case, which is the most important one. In this case, you have been given a quadratic equation x square minus a minus b times x plus b minus a is equals to 0. And you are asked to find the same thing here too, 1 by alpha plus 1 by beta. Here, coefficient of x is the negative of a minus b, coefficient of x square is 1, constant term is b minus a. As alpha plus beta is equals to the negative of coefficient of x divided by coefficient of x square, alpha plus beta will become equal to the negative of minus of a minus b, which is equals to a minus b. And as alpha beta is equals to constant term divided by coefficient of x square, alpha beta will become equal to b minus a divided by 1, which is equals to b minus a. Now let's solve for 1 by alpha plus 1 by beta, which is equals to alpha plus beta divided by alpha beta. Substitute the values of alpha plus beta and alpha beta. Take squares on both sides. Therefore, right hand side becomes a minus b whole square divided by b minus a whole square. Numerator and denominator will be cancelled according to our formula. As a result, 1 by alpha plus 1 by beta whole square will become equal to 1. Transfer the square to right hand side, it will become root. As the root of 1 is equals to plus or minus 1, 1 by alpha plus 1 by beta will become equal to plus or minus 1. Plus or minus 1 indicates plus 1 and minus 1. So 1 by alpha plus 1 by beta is equals to plus 1 and minus 1 also. Now, if you solve this in a general way, the final answer you get is minus 1 only. You don't believe? Okay, then let me prove it. 1 by alpha plus 1 by beta is equals to alpha plus beta divided by alpha beta. Substituting the values, in the denominator take minus as common and the denominator becomes minus of a minus b. Now both a minus b will be cancelled and finally the result you get is 1 by alpha plus 1 by beta is equals to minus 1. So finally this concludes that you cannot solve problems related to second case without using the formula a minus b whole square is equals to b minus a whole square. But wait a second, you might be a person who is passionate of space and the night sky, but you don't have any idea about stuff related to astronomy and don't even know what is astronomy. Then you must watch this video displayed here. And don't forget to watch the proof of my formula by clicking here.